Hello, pre-algebra friends. We're going to talk today about the next section in the book, and I'm sorry I can't be there with you. I hope you find this video helpful, and I hope you can also use it to do your homework while I'm away, and then you can ask me any questions you have next week when I get back. So we're moving on to 5.6. We're going to talk about reciprocals, and we're going to talk about solving equations, and we're also going to talk about this little word right here, multiplicative inverse. It's such a fun word to say, and if I were there in class, I would have you say it, multiplicative inverse. So we talked in 5.5 about reciprocals. And to remind you, when you multiply any number by its reciprocal, the product was 1. So some examples were 3 over 4 times 4 over 3. The numerators cancel, the denominators cancel nicely. Everything cancels, and our friend, the ghostly 1, is left. We also talked about reciprocals having the same sign as the original number. So if you had negative 6 over 1, its reciprocal would be negative 1 over 6, and your answer turns out to be a positive 1. So any number times its reciprocal is 1. And we're going to use this information to actually go back and solve some equations, which we haven't done in a while, so we'll need to review that a little bit. But another term, another word for reciprocal is multiplicative inverse. So some math books use reciprocal, some math books use multiplicative inverses. They mean exactly the same thing. So before we actually read what this says right here, I want to review our steps for solving equations. We started solving equations in Chapter 2, and these were one-step equations. And then in Chapter 3, we solved the more complicated 2+ steps that involve distribution and collecting like terms, lots and lots of solving equations. These would be the chapters that you could review if you need to go back and remember how to do this. These were our steps for solving equations. Number 1, we looked for distribution. How did we know there was distribution? We looked for grouping symbols, and most often it was the parentheses that we looked for. We took care of the distribution, then we collected any like terms and any like variables. And also we had to get our variables, get all variables together on one side of the equal sign. Then we did the addition and subtraction. Finally, we did the multiplication and division right before our check. And remember, this is a different order than PEMDAS. This is actually the opposite right here of PEMDAS. So I printed these up on the notes so you would have these in front of you as you're solving equations. So we are going to use the multiplicative inverse or the reciprocal idea to clear out a coefficient of a variable as our very last step in solving an equation. So as a reminder, we're going to box up our equation and we're going to rewrite it. This is actually just a skills check. This is from way early back in Chapter 3, just to remind you. We're going to subtract 14 from both sides. We're going to line up our equal signs nice and neatly, and we're going to have 5x equals negative 10, divide both sides by 5, the coefficient of the variable, and x is going to be negative 2. And we said we checked it by going back to our, I'll go get another color here, we'll go back to our original equation, and we will plug it in. 5 times negative 2 plus 14, does that really equal 4? We hope so. Negative 10 plus 14 equals 4, and yes, it does, and our check is complete. I will leave number 2 for you to do on your own. It's similar to number 1, and I think we're ready to move on to the current lesson. So we are going to solve these equations a little bit differently because the coefficient in front of the variable is a fraction. So when you rewrite it, you're asking yourself, okay, the variable's not alone. He has a fraction in front of him. And we could say, well, let's just divide both sides by 2/3, which is what we did if we had something as simple as 3x equals 36. We divide both sides by 3. Over here, we've got 2/3 x equaling 36. So we can say, well, let's just divide both sides by 2/3. But what happens when you're dividing by a fraction? You make it a multiplication problem. So really what we're going to do is not write it like this. We are going to write it as the multiplication of the reciprocal, which is what we do when we divide by a fraction. We invert and multiply. And if you multiply both sides by the reciprocal, this guy is the reciprocal of this guy. When you multiply, you can see your 2's cancel, your 3's cancel, and you're left with x alone on that side, which of course is what we're looking for. Over here, we have multiplication of two fractions. We can think of a single fraction bar. 36 is 18 times 2 times 3, 2 on the bottom. The 2's will cancel nicely, and x is equal to 54. That's if we did our work correctly. Let's do our check. 2 over 3 times 54 over 1. Does that really equal 36? We'll find out. Single fraction bar. 2. 54 is 18 times 3 over 3, equaling 36, we hope. The 3's cancel. 18 times 2 is 36. So our work checks. Let's try the next one. Box it up and rewrite it. Negative 11 over 18x equals 1/3. The x is not alone. His coefficient is negative 11 over 18. I'm going to multiply by the reciprocal of negative 11 over 18, which is negative 18 over 11. Both sides, negative 18 over 11. Don't forget to put parentheses because you'll turn it into a subtraction-looking problem if you don't. This is all multiplication. These guys cancel. 18, goodbye. 11, goodbye. A negative times a negative makes a positive 1x on this side. On this side, we have positive times negative, so our product is going to be negative, single fraction bar. 18 is 6 times 3. Here's 3, and here's 11. They're both prime. The 3's cancel, and our answer ends up being negative 6 over 11. We think the check. It looks kind of hairy, but it is pretty easy, really. We go back to the original problem. Negative 11 over 18 times negative 6 over 11. Does that really equal 1/3? We're going to find out. We know it's positive because a negative times a negative is a positive. That's a good thing. Single fraction bar. 11 times 6 over 18 is 6 times 3. There's another 11. Does that equal 1/3? We're getting closer to the answer. 11 cancels, 6 cancels, and we have the ghostly 1 in the numerator. 1/3 equals 1/3, and we're good to go. Let's do a couple more. All right. Number 3. Box it up. Rewrite. Now we've got a two-step equation. We're going to do our addition before multiplying by the reciprocal. So we have 1/2 x equaling 5. Multiply both sides by the reciprocal of 1/2, which is 2 over 1. So we have the 2's cancel, the 1's cancel, positive 1x equals 5 over 1 times 2 over 1. Or x is equal to 10. And I'll leave the check to you. I want to move on and do number 4. Let's see. I'm going to box him up. I'm going to rewrite and move over a little bit. Minus 8 over 15x minus 12. I hope you see that we're going to add 12 first. Get rid of that guy. And get 32 equals minus 8 over 15x. Now we're ready to look at the reciprocal. The reciprocal of negative 8 over 15 is negative 15 over 8. Both sides, negative 15 over 8. Negative times negative makes positive. The 8's cancel, the 15's cancel, and you're left with just positive x. But over here, we have a little bit different story. We've got some stuff to clean up. We've got negative 15 over 8 times 32 over 1. Let me continue this over here. Single fraction bar, negative 15. 32 is 8 times 4. We have an 8 on the bottom. The 8's cancel. And 15 times 4 is 60, and it's negative. So that's how you work these. It's really not very difficult. It's it builds on the stuff that we've learned before, and I hope that these examples will help you when you're working at home. I want to talk about one more little thing. I want to talk about, and I think we did in class talk about that x over 3 and 1/3 x are the same thing. And they are because if you think of what 1/3 times x means, it means 1/3 times x over 1. There's nothing that will cancel top and bottom except these x's, and when you put it over a single fraction bar, you end up with x over 3. So 1/3 in front of the x is equal to the same thing as x divided by 3 with a single fraction bar. And this is another example. If you think about what 2/3, this example right here, 2/3 times x really means, it means 2 over 3 times x over 1, single fraction bar, 2x over 3, which is this guy right here, 2x over 3. So they look differently, but they represent the same value. I want to work one more, and then I'll leave the rest, I think, to you for homework. Let's work number 5, if you can box it up and rewrite it. First thing I want to do is the subtraction piece. So we're going to subtract 4/5 from both sides. Now, this gets a little messy because I can't subtract 4/5 from 1/3. I need a common denominator, which would be 15ths. So I can rewrite 1/3 as 5/15 minus 4, no, not 4, sorry, made a mistake. Get back in. 5 goes into 15 3 times, 4 times 3 is 12. So 5/15 minus 12/15 is negative 7 over 15. That's what this side is. We've still got the negative 11/15 x over here. One more step to get the x alone. Multiply by the reciprocal of negative 11 over 15, which is negative 15 over 11. Negative 15 over 11. So that leaves x alone. A negative times a negative is a positive. I've got a single fraction bar now, 7 times 15 over 15 times 11. Cancel, cancel. And x is equal to positive 7 over 11. 7/11. So let's see. I think I'm going to leave the rest of these for you to work. This recording is about 15 minutes long. I think it's long enough. When you look at number 7, please think about subtracting this 12 first instead of dealing with the 3/5. Your addition and subtraction come first. Go back and look at all of our examples if you need to see this video more than once, please do, and I'll look forward to working some of these with you when I get back. Thanks, and have a great day.